So let's take a few minutes now and summarize everything that we've learned about this so far. Okay, so what does this look like? Our new equation for parabola, our old one was just plain old f of x equals to x squared. But look at all the fun stuff we put on this. For example, we put an a in front. Now, if you remember, the a here controls how wide or narrow, and it also controls the direction of the opening. So if a is a big number greater than 1, this becomes narrow. If a is a number between 0 and 1, that means it's a small decimal, it's a fraction less than 1, this turns out to be quite wide. But on the other hand here, if our a is greater than 0, that means it's positive. It's a positive value. It opens up, which means, look at this. One thing that we didn't talk about is the fact that it will have a minimum value. So we can call this our happy parabola. If a is negative, okay, this opens down, so we call it our sad parabola. And sure enough, a sad parabola, yeah, has what we call a maximum value. Okay, now, do you remember what else we did here? Yes, we played with these values called P and Q. Now, P was inside with the X, so that ends up being our movement left and right. This Q ends up being our movement up and down. But look what happens. When I move something to the left, or to the right, I should say, and up, and I put it here, what does that value become? That value becomes our vertex. Oh, interesting. So our vertex is actually PQ, these values right here. And that's why it's so important to know this formula. And this you have to memorize. No ifs, ands, or buts. You got to memorize that. That's really, really important. So that vertex is at PQ. This P value, this Q value. We have a maximum or minimum determined by, of course, if it's opening up or down. But the cool thing is our maximum and minimum is right there, our Q value, our up, down. There's our minimum on this case. And if we looked at a maximum going this way, and let's say up and down that way like this, look at this. Our maximum would be, yeah, the Y value. And our axis of symmetry is right there or right there, which of course is our X value, our P. Look at that. Isn't that interesting? So we got a lot of stuff here that we have to know. And trust me, by the time we go through enough of these podcasts, enough examples, you'll get it. Couple extra things here that you have to know. When we deal with math, we end up dealing with words. The words, by definition, mean do this. For example, if we're talking about a horizontal translation, we're moving left and right. If we're talking a vertical translation, we're moving up and down. And the changes to the A value, making it wide or narrow, we refer to it as more commonly now, not the compression. Compression's not a word that we use much anymore. We call it a stretch. Okay, so we're going to stretch it, and we're going to stretch it vertically, right? Vertically. Because if you remember, when we originally did this, we had a value here, and then when we stretched it to be here, that value got stretched upwards, vertically, okay? And if we had a negative, we'd call it a reflection. So, for example, if my equation is y equals to 5x squared, we know that 5 means something. That 5 becomes a vertical stretch factor. And we actually refer to it as a vertical stretch factor of 5. So look at this. The negative 3 would mean we have a vertical stretch factor of 3, but then a reflection. In other words, we're flipping it to be a sad parabola. Look at this one. Even this, even if it was a third, we would call this a vertical stretch factor of 1/3. We don't use the word compression anymore. We stay this as a stretch. But it's the factor of 1/3 that tells us that this is going to be wider. Okay, so hopefully all of those words come together in our next little podcast. We're going to use all of these words and all of the stuff that we need to memorize in the next couple podcasts. Stay tuned.